Question 5 says, rank the following emissions in terms of increasing frequency, wavelength, and energy. So basically, what I've written is the orbital diagram for hydrogen. And you'll see that we have n equals 1, 2, 3, 4, 5, and 6. And what we want to remember is that as we get further away from the nucleus, so say the nucleus is here, as we get further away from the nucleus, these ends get progressively closer and closer together. So the distance between 2 and 1 is greater than 3 and 2 is greater than 4 and 3 is greater than 5 and 4 and 6 and 5 until you get to the difference between n equals 100 and n equals 101, and they're essentially the same. So these are basically how the diagram works. Now all of these things are emissions. How do we know? Because we're starting at n equals 4 and we're falling to n equals 2. So this atom of hydrogen is losing energy. Well, where does that energy go? That energy is emitted as a photon, and that's where light comes from. So this gets excited to a higher energy level using electricity or using heat or using other light, and when it falls back down, it emits a photon, and that's where the light comes from. So let's look at the photon that it emits. Well, the difference here is in terms of energy. So if we look here, 4 to 1 is the greatest energy, because you can think about energy as essentially being on this axis, and basically when this drops from 4 to 1, there's a big gap. When it drops from 4 to 2, there's a smaller gap, and when it drops from 6 to 4, there's even a smaller gap, or the photon has less energy. So if we look here, the highest energy is going to be the 4 to 1, which I know is backwards because it has highest energy on this side, but B is going to be the highest energy. What is next? Well, if we go from 4 to 2, that's going to be the intermediate amount of energy. 4 to 2 is letter A. And if we go from 6 to 4, that's going to be the smallest amount of energy. And notice that this is still a gap of 2, but since this is further away from the nucleus, 6 is further away from the nucleus than 4, this is always going to be less energy than this because these orbitals get closer and closer together as we move further and further away from the nucleus. So the answer here is going to be C. Remember from the previous question that the frequency is in the same order as energy. So C less than A less than B, and wavelength is going to be the opposite, exact opposite. So shortest wavelength is the highest energy, which is 4 to 1, which is B. A is still intermediate, right? Because we're going from 4 to 2. And then the longest wavelength or lowest energy is going to be your 6 to 4, your last one here, which is choice letter C. So that is basically how we can rank these things.